So my cat is on a shelf above me and seems to be sleeping down safely. Okay, cats are cool. All right. Well, happy Friday, everyone. Let's get started. It seems like we have a good number of folks here. So today's topic is a topic. It is going to be, we're going to be building a little diffing tool. So if you've ever used, I don't know, I think diffx is one. There are probably some other diffing tools as well. I'm not entirely sure what diffx does. I made one a while ago for Zeotest that's kind of built into that. So it's going to be sort of exploring that as just sort of a nice functional domain. It's kind of going to be a bit of a type class, I suppose. We might use, I know, but in this case,
we're going to make it okay.
Yeah, like, you know, like an encoder or a decoder, there's sort of, we want one instance per type. We want it to be globally accessible. We want to use sort of the power of implicits to synthesize new combined instances based on our types. And we might use Magnolia to generate other instances for us as well. And one of the purposes of this might be, not cats, Zeo. That's, might be, no, I'm turning you off, Copilot. Might be for JSON diffing. That kind of is one concrete instance. We have ZeoJSON, and you can compare JSON instances, but it might be nice to get, you know, accurate diffs of exactly what has changed in there. And I don't think we really need to do anything special. I think we can make it generic and then just write an instance for a JSON AST. So maybe we can get through all of this today. We have a good deal of time. So let's see what happens. I think we're going to start with just sort of the basic understanding that people kind of understand the type class pattern that we'll be using, but I'll try to walk through it, and feel free to ask any questions if anything is confusing about that. But let's just start with what I'm even intending this to look like. It's always good to know kind of like what your goal is before you just start coding. Sometimes it can be fun to just start coding, just totally untethered from all reality, but soon, if that doesn't prompt or sort of spark a concrete goal, then you might find yourself adrift. So today is a goal, yes. Well, I've already written that. Okay, so what would it mean? What do we want when we diff things? So we kind of want some differ type. So this type class, and yes, it's going to basically take two values, maybe an old and a new value or something, or an A and a B, a left and a right. A1, A2, I'll call it, I guess. And not going to get a string back. We want to get something back. We're not really sure what yet. I will copy Adam's type level question mark technique. I wish I could. So we don't know exactly what we want back from this, but we do know we want to diff it. And sometimes if you're not sure what structure you want back, you could say, well, what do I want to do with that structure? I guess at some point, whatever this thing is, whatever this, maybe I'll even just rename this to diff result. So whatever this diff result is, I want to be able to, well, ask, you know, is it different? And sort of get back a Boolean. So that's one thing we want to do. And we do also want to render it and be able to get some kind of nice string representation that we can put out to the console. I guess that's mostly it. I mean, if it is an interesting structure that knows both of these things, maybe we could get other information out of it. But those are kind of the two things. But because we don't want to just render it, we don't want it to just be a string. We want it to be some kind of other structure that we can derive a string from, that we can derive is different from. And maybe to sort of further contemplate its structure, let us think about a concrete output that we might want to generate. So let's say we're diffing two numbers, right? 10 and 25. Well, these are clearly going to be different. So we want it to be true, whatever the result is. And maybe the representation is just like something like this, right? So if we diff 10 and 25, the string rendering is just going to show we used to have 10, now we have 25. It's different. Fine. Maybe it'll be the same thing for strings, though you could do other things eventually, like use Meyer's algorithm for diffing and to get exactly which characters have changed. But for now, let's just keep it simple. When you diff these things, you're going to get just like, here's the old value, here's the new value, etc. And if they're identical, maybe you'll just see the old value or something like that. But where it gets interesting is when these things are nested. So when we have maybe a list or maybe a map of these. So let's say we're going to have 1 goes to 1, 2 goes to 2, and we're going to diff map 1, 1, and 2, 3. So 2 is now set to 3 instead of 2. What do we want this to look like? And I mean, we have a lot of flexibility, but I've thought about it a little ahead of time. And I think what I want is sort of, it will show the values that are the same. So 1 is going to be equal to 1. Maybe I'll use some terminal rendering to make this sort of faint or something. And then for the values that have changed, we can then say, well, 2 used to be 2, and now it's 3. And we can sort of maybe show that this has changed. Maybe we could have a little mark there or just use terminal coloring to show that there is a change at this key. Furthermore, let's say there used to be 3 here. So 3 used to be 3. And now there's a 4. So let me put these on one line. So yeah, 3 has been removed, 4 has been added. Okay, so maybe I will want to show that 3 is no longer, with a little minus there. It is aligned. There seems to be a slight, this should be aligned. Anyway, and that 4 has been added. This should be a monospace font. I guess the italics might be throwing it off. It's slightly misaligned. I think it's because it's interpreting that as a bullet point or something. Painful. Okay, so yeah, so this is kind of the output I'm imagining for a map. But this could also work exactly the same for, let's say, like 2 people that you diff, except instead of being a map like this, it's going to say, okay, well, you had a person, maybe their name is still Kit, but their age has changed. I used to be 2 and now I'm 3. Obviously, with case classes, you're not going to be able to add or remove values. We want to generate a structure that's going to be able to render these different ideas. One other sort of thing to think about would be maybe a list, where we probably want to have values that stayed the same, and maybe values that changed, as well as values that have been removed at each of their indices. Maybe to make it identical, we could have like an index prefix, or that could be optional as well, not entirely sure. We can make it flexible. So at index 3 used to be 5, but it has been deleted, and now we added an index. Well, that doesn't really make sense in this case. You're either adding or removing in the case of a list. I hope that kind of makes sense. So that's kind of the vision for some semi-useful output. And this could mostly be useful in testing scenarios, but also just whenever you really want to know what has changed exactly between 2 data structures. Where the indices might be useful is one might have a rendering mode where you just do not want to show the indices that remain the same or the values that remained identical. You just want to focus on the differences, and therefore it would look, you just wouldn't have enough information if you didn't store those indices. But perhaps if you are showing everything, it would be a little annoying in the list to see those. So hopefully we can design something that'll potentially allow that amount of flexibility in the future. But for now, I think I might, just to have everything be consistent, focus on this kind of output. So ideally, the implementation would generate some kind of diff result structure that we could render into these different types. And as we see, we kind of tried to make them the same in some way. There are these sort of changed values that exist. There are values that get added. And then sort of the leaf nodes, that there's a change. And then these things kind of are these nested diff results, where there are these product types, some kind of product diff, where they have these different labeled fields where they can each have their own diff results. And of course, a person might have a map inside of it or something, or a person might have a pet, which might have its own diff results inside of it. So it might have gone from 5 to 37. And therefore probably something else. Okay, with the facts of pets. Okay, great. So I hope that makes sense. Any questions on sort of that overarching vision for a diff library? If anyone has any other bonus ideas, maybe we can add them. But I think there's enough to get started with here.
Yeah, I I think we're good so far.
Okay, cool. So now that we have this idea, I kind of see a few potential patterns. So let us sort of start with the sealed trait for this diff result thing. So instead of being a type alias for nothing, let's actually make something concrete here. And I think what I want to start with is not quite this, but yes, if it's identical, then I want to have a value in here. And I could give this some kind of type, I suppose, but I really am never going to care about what the A is in here. So I'm just going to make them all any. Maybe we'll eventually want to change that. But really, these values are only going to be used for basically turning them into strings. We could even pre-process them into strings, but I'll keep them any for now. Excuse me. So yes, if the values were identical, so if we sort of did 10 diff 10, then well, we don't need to store both the left and the right side because they were identical, right? So we could just have value any here. But then there's, of course, I guess I'll call it different. And that's when we did have the left and the right-hand side, and these were different. So these are kind of the leaf nodes where, in this case, we tried to diff 10 and 8 or something. Okay. And then we have the case of these maps, right, where you have whatever. Yes, this sort of example. And then there was also the case of a person, right, name, John, age 30 and 31, and so on and so forth, and of course list as well. And these are all kind of similar, and I would like to express them all in the same way, just so we don't have like a million different nodes here. So maybe we could call it, I don't know, I'm just going to call nested. I guess I could call it product or something. And I think what I need here is basically a name, sort of the constructor. So I can have map, list, or person. And then I have these different sort of labeled entries. So I'm going to try this for now, which is labeled or labeled. I'll call them labeled. And so we want a list of basically strings and then subdiff results, extends diff result. And I might just make a case class here called labeled with a name, string, or the key, I guess. I'm not really sure. Maybe we should call it label and label, and then a value, which is going to be another diff result. So we're going to have a list of labeled things. And that might handle that. Of course, then there's the idea with these nested types that you might have either added or removed something. I guess there are a few different ways we can factor this out, because really only in these nested types is it even possible to add or remove values. You cannot, if you're diffing 10 and 10, you couldn't have removed 10 from 10 or something like that. So perhaps in here, this should really be sort of a list of something that's like a sealed trait. That's whether or not it's been removed or added or something. That might make it more correct, because removed and added really only makes sense in this context. But for now, I might just keep going like this, and we'll see if this makes any sense. So I'll just have added value any, and also removed value any. So a couple more base cases that really only make sense in the context of nested. Maybe we could figure out a way to refactor this later on once we use this, but I see if we run into any troubles. But that's kind of the thing that I'm imagining here. And so maybe we could sort of construct one of these for this and see if we could render our example. So like just doing it by hand before we do it in an automated fashion, just to see if we're onto something. So let's have example, and let's see if this can figure it out for us. And it certainly can, which is kind of cool. So yeah, map 1 identical, 2 is different, 3 is removed, and 4 is added. And so that kind of tells me that, yeah, well, if Copilot can figure it out, maybe it's not the worst thing in the world, at least. Copilot's pretty clever, but I'm proud that it discovered that. Okay. So now let's try to render this, our simple example, and see if we can get something kind of like this output. So I'm going to make a render method, which is going to turn this diff result into a string. I'm going to match on ourselves, so on these different cases. And I think I'm just going to sort of, well, for value, I'm just going to, I guess, turn it into a string, or I can use, yeah, that to stringify it. For the different case, let's see if it's smart enough to just sort of do this. It kind of is. Yeah, and then the nested case is a little more complicated. I kind of want a multi-line thing. Personally, I like, for whatever reason, maybe this makes people crazy, but I kind of like doing this. And I'm going to say rendered labels. So I'm going to handle this above, and we'll throw the rendered labels down here. So for each of these labeled, well, we want to render them. Unfortunately, that's its own type, so there is no method called render on them just yet, but maybe we could just inside of here do a little case match and just throw all the logic in here, make it a little ugly. So case labeled, label, diff result. And yeah, maybe we'll do something like, I guess we wanted the equal sign. Diff result dot labeled. Make string. Great. Okay, I don't think this is quite complete. It's going to look a little ugly because it's not going to be indented. And we can fix that momentarily, but let's just for now try to print our example rendered and see what we have so far. And let me also bump up my console font size so we can actually see what's going on. 28 should be nice and ugly.
Yep.
So yeah, I mean, it's kind of like what we planned out. Let me get what I wanted. It's sort of like this, except the plus and minus is on the inside of the value, which I guess kind of makes sense because of the way that we architected these labeled to contain other diff results. And this might be an argument for slightly refactoring this to have sort of the labeled be this sealed trait that's either added or removed or sort of nested in itself. Maybe I can do that. Yeah, let's try that. I actually don't think I've done that before, but I think that maybe makes it more correct because these added and removes really only make sense inside of here. So let's do this. Case class, so added, label string, value any, extends labeled, removed, and then there is, I guess, modified, but this could be a whole other diff result. Or I guess this is going to be, it doesn't even necessarily have to be different. So I'm going to call, I already called that one nested. I'll just call it diff. We're inside of this other thing now anyway, so let's just do that. So now maybe we're a little more limited in what we can express, and let's see if this can figure it out. What we need to do. Oh, for this to figure it out, we need to put the example above our code because GitHub Copilot only looks above your current line to generate stuff. So there we go. I'm sorry for always being an advertisement for GitHub Copilot, but it's like made me so much more productive.
That's really good.
kind of insane. So I think it's actually worth learning how to code with AI and sort of get it to kind of help you. So yeah, added, not quite that. I don't know what that was about. This would have been actually, so yeah, I got it wrong. Bad GitHub. So this would have been identical. That would have been added. This was removed. And these are both not added, but these are diffs, where this is going to be identical of 1, and this is going to be different of 2 to 3. So that's the structure that I would expect there. So now you can only have removed or added inside of nested cases and not as leaf nodes, which we could have made it correct by construction and not exposed APIs that would have allowed such a thing, but it's kind of nice if your sealed trait enforces that in and of itself. It's not always possible to do that conveniently. It's not always convenient. But now, yes, now we have a few different cases. So let's actually match on all of these. And I guess I will just do this. Great. And now, cool. So now we have the plus, the minus, and the recursive result, which is not too bad. Okay, maybe I'll just put this like that though. Okay, and then now I don't need to handle these here because they're handled inside of the nested case. And let's print again what we have so far. And now, yay, it looks a little better. There's still, I guess maybe I do want the spaces there to line them up, but this might get awkward when things start getting nested recursively. We will see. But yeah, I mean that's basically it. So we're able to have this default renderer for our diffs. The only problem is we sort of had to write it by hand, which is not a good thing for a library, for a diffing library. You don't have to write your own diffs. You wanted to figure it out itself. So now that we have our AST here for this diff result, yeah, I'm happy with that. Now that we have this AST and this little example, we can start to actually, we have a render method, we can actually work on our differ. So now that we sort of have an idea, I'm going to delete some of these comments and make an object, a companion object for our differ, because this is where the instances are going to go. And I don't know if this is, if seeing this workflow is useful. I hope it is. I personally really enjoy watching people like work because I figure out like tricks that they wouldn't have explained to me or put in blog posts otherwise. And I think something that I've settled on over the years is just trying to get as many feedback loops as possible. So making simple examples, rendering them, repeatedly rendering them, just making this main and just running something over and over again and looking at the output. Probably other people do that. But if you don't, I would recommend trying to create little feedback loops for yourself, just to experiment constantly. If you're not running your code all the time, you're probably not learning as much as you can. You really get to form little hypotheses, validate them, screw with things, experiment. It's pretty lightweight in Scala to do that, especially with a good IDE. So highly recommend doing that. Great. Boom. Okay. Cat chaos. All right. It's kind of funny. There was a plumber earlier, and but not in our apartment, in another apartment, and I didn't know that, but I did know that it sounded like there was this crazy scratching happening from inside of our bathroom, and I was like, "Is a cat trapped in the bathroom?" And then I looked around. No, all of our cats are accounted for. We opened it, and there was a drain snake coming out of our sink onto the floor, like wiggling around in the air like an insane snake. It was very frightening. Or unsettling and kind of disgusting. But anyway, where were we? Yes, differ. So this is where we're going to make our instances for differ. So I'm going to basically go through some base leaf types. So a string differ, let's just have it kind of do it itself. I'm going to do this myself. So we're going to make a new differ of strings. So how do you diff strings? Well, it's going to be pretty basic. If they are identical, if they are equal, then they're identical. If they're not, then they're different. And that's going to work the same for basically a lot of these sort of any val types or basic types. We might eventually get into having a sort of a low priority differ that works for everything, but for now, let's just pretend like these were slightly special and make some concrete instances here. So we'll have our string differ and int differ. No, let's do a Boolean differ or something. Come on, Copilot, save me a type. Great. So yeah, boring leaf instances, non-recursive instances. And now we can get to the more interesting one, which is going to be our map differ. So map differ is going to work given that we have a value. No, I don't really want you to disable Copilot temporarily.
I know, it takes away all the surprise.
All the fun. Okay, no, I did not disable it successfully. It's a weird shortcut. Which one is it? I think that's it. Nope. Okay, disable Copilot. Command, okay, Option Shift Command O. All right, I think I was hitting that, but great. So we basically want to get back for a list of key values, right? We want to get ourselves a differ for a map of key values. And we can start with this. So new differ, map key value. Great. So we have one map on the left, one map on the right. And this is where it can be useful to just start implementing stuff, potentially. Maybe starting with the end result. Well, we know we want a diff result. And really, it's always going to be, I think, we can make a decision, but I think we might, I guess we could see if they're just actually equal or not, and then make a determination there. So I guess, yeah, we could say if A1 is equal to A2, then we can return diff result at identical A1, else now we can, in this branch, be much greater. Maybe I'll just even do an early return just to sort of not have to be nested. So yeah, if we're that, we're going to return early, sort of a guard clause. Otherwise, we're going to basically always be diff result.nested, and we want our constructor to be map. And then in here, we need to come up with a list of labeled. So val labeled equals a list of labeled. So we basically want to figure out, if we remember how we make a labeled, there are three different kinds. There's a difference, added and removed. So added and removed are actually, should be all right. Oh, by the way, okay, I was just matching on that. All right, sweet. I wasn't sure if it figured out that label was identical between all of them and added it as a method, but I did not call a method on these. I could probably add and should add a method to this called label, which is a string, just in case. We probably won't ever need that, but crossed my mind earlier. Okay, so let's go back to our map implementation. So we need a list of labeled. So we need to basically figure out which keys have been added, which keys have been removed. And then for the overlapping keys, we need to calculate the diffs of the values. Great. And so what does it mean to find the keys that have been added? And yes, so we're going to basically need a differ for the value, which is kind of implied here. I didn't add that yet because maybe, you know, if we started adding everything, we might also think we need differs for keys or something. But really, if you think about what needs to happen here in terms of the algorithm, we only need to diff recursively if the keys overlap. So we're not even going to worry about diffing the keys in this case. It doesn't really, like, maybe you can come up with a version of a differ that does do that, but seems complicated.
Well, we're kind of defaulting to Scala's hash code for the definition of equality here, because that's kind of what's built into this map. So yeah,
yes.
I think we just kind of have to accept that.
Yes, it would probably be very strange looking output as well. Yeah, I don't think we would want that. That's not how we wrote our examples before, and it would look pretty, I don't really know how you would render diffs of the keys as well as diffs of the values. I don't think that would feel very natural, but maybe it would. That would be if anyone can come up with a cool implementation that makes sense, let me know. So yeah, what does it mean to have keys that have been added? Well, those are probably the keys that exist in the right-hand side that do not exist in the left-hand side. So the way we can figure out the added keys, if Copilot were here, it would tell me that we want to take the key set on of the new keys, A2, the right-hand side, and subtract the key set, or get the difference, remove all the previous keys. So these are just going to be the keys that exist on the right-hand side, not in the left. And then for the removed keys, we just flip this. And I probably want to pull these out into about, if I cared about performance, would pull these out into, you know, let's do this. New keys. And then these are all the old keys. Oh. Sometimes things act a little wacky. Old keys. The intersection of Vim mode and refactoring tools and everything else gets a little wacky sometimes. Okay. So we have the added keys, we have the removed keys, and then we want the overlapping keys, which is actually just going to be, I'll call these shared keys. We can just get the intersection of the new keys and the old keys. And that's a little symbolic alias for intersection that comes on sets. Oh, great. So now we have all these keys. And if we get the union of all of these keys, it should be every key in each of the maps. So we can just operate on these keys and we don't really have to worry about anything else, theoretically. Great. So now we can, maybe we can actually do val all keys and get, may as well make every possible combination of this. Union old keys, great. And then we could basically go through all of these keys, map, key. And I mean, there's different ways we could do it. Let's see, but if added keys dot contains key, let's just do it this way. This is, not terrible. Labeled dot added, and then we can basically, we know then this is in the right-hand side because it's been added. And we want the key name, so key. This needs to be a string, so toString, and a key, great. And you can kind of get the idea. Else if removed keys contains key, then we'll say removed, and it's in the, oh, actually, I think it needs to be A2. That's the right-hand side. I should probably rename these as well. And because I'm kind of semantically in here, have a sort of a new map and an old map idea, I think it's nice to sort of name everything, give everything the same semantic view in sort of at this level of abstraction, right? Where we have this idea of adding and removing instead of doing X and Y and A and B. Like the more we can sort of view everything through this lens of added and removed, I think the better and less likely we're going to introduce bugs instead of having to sort of recompute the meaning in our heads every time we look at a variable name. Okay, and otherwise, if it's not in the old or removed keys, then it means it's in the shared keys. So we could basically just do labeled dot diff, get the key to string it, and then this is where we use our recursive implicitly found, and this should be implicit too, forgot to do that, our implicitly resolved differ for the values. So it's ever only going to generate a map differ for us implicitly if it has a differ for the value. So it has to now currently be a map where the value is either a Boolean, an int, a string, or another map of ints, Booleans, or strings, or nested any amount of times, etc. And so we can use this thing that's been supplied for us magically by the compiler to diff basically the old new. This is what I get for talking. Old new. I'm sorry if anyone saw that. I try to be all right at talking and typing at the same time, but occasionally the wires cross. So old map and new map. Old new would not be a good name. So we want to diff the old value at that key and the new map's value at that key. Great. And then we get here a set of labels because of course all keys is a set. So I might just turn this into a list ahead of time. They're already distinct because I've unioned them as sets. And yeah, now everything compiles. And I guess I didn't really need shared keys because I'm going through all of them. If I wanted to, I could have processed these separately and I wouldn't have to look them up because I knew based on these things. But I the reason why I did it like this is because though maps are not ordered, I kind of wanted the nice aesthetics of maybe there will be some randomness or ordering that's persisted here. And it won't just be all the deleted ones and then all the new ones and then all the shared ones. And maybe there'll be some sense of ordering perhaps. That could be nice. More aesthetically pleasing instead of just all the removals and additions at the end. So I'm going to delete that. Great. And I think the names here are all that's necessary instead of the comments there. And now we have it. So not the most complicated algorithm in the world. Pretty basic, probably could be faster, but if we think about the context, I'm not going to hyper optimize this right away because we're just using it if a test fails, basically, or in tests. Maybe it's worth optimizing, but not now. Cool. And now that we have this, let's try to use it. So let's go back up to our example where we had this thing before. Actually, one step first, because we don't really have a nice way of using it. I'm going to make a method called diff on here that's going to basically summon an implicit differ of A. And then we're going to also, yes, take two A's, A1, A, A2, A, and call differ.diff on these, A1 and A2. So then we'll get back ourselves a diff result. So now we can let implicit resolution do its thing. And basically, let's try the same exact thing here. So I'm going to re-enable Copilot for the boilerplate generation. enable copilots. There we go. So val map 1, 1, 2, 3, map 2, great. And that seems to have reverse engineered it from our example. So we have our example from before, but now we should be able to just say differ.diff of map 1 and map 2, and then render that result. And it should be sort of similar if we've done anything correctly. And it is, if not identical. Maybe it's not identical, I don't know, let's see. But yeah, looks identical to me. So now we don't have to hard code our diffs any longer. So goodbye, example, you were useful, but now no longer. And now we can make things even more complicated by basically, I can make a map and say first, and then we can have another map. First, and we can make things crazy and nested. So then I can have, second is an empty map for maybe both of them, and then I'll add one to the. So fourth is going to be a map from hello to 300, and then there was going to be
there was a good suggestion to enable the show implicits thing so that we can see how it's finding them.
Yes. I was going to do that with this, but no, that's a great idea. So yeah, now let's show implicits. There are two ways of doing this. First, I'll do the show implicit hints. So show implicit hints. Just remember Control Option Shift equals. I hate that shortcut. Talked about it before, and we actually see. For some reason, can I expand implicit hints? Yes. Good. So now it's showing sort of the full path of methods that it used to synthesize at compile time our differ here. So it made a map differ of a map differ of an int differ. And that's because the types that we're dealing with here are maps of ints. So if we were to become the compiler, what would happen is, well, we say, okay, you're calling this method with a map of an int. And it would sort of start by saying, okay, do we have an implicit for this? Maybe you hard coded an implicit for a map of an int, and it would find that. But since we didn't do that, it's going to instead sort of start from the outside and see, okay, do you have an implicit of a map? And we do, given that there is an implicit for the value. We have a map from any key to any value. We have an implicit differ for that as long as there's an implicit differ for the value. So then it sort of recurses in its search and says, okay, well, do we have an implicit for a map of int? And it'll obviously be taken to the same method, but now the value is a different type and it's an int. And so we'll now recurse one last time and look for a differ for an int, find one, and then we're done. And so it's basically going to call that map instance twice. So it's going to call map differ, and then int differ, which is exactly what we see above. And if you don't like the show implicit hints thing, which can be useful, of course, but if you just kind of want to do it quickly, if you hit Command Shift P, at least on a Mac, it'll just show you the implicit arguments for whatever you have selected under your cursor. And it can jump you to the implicits that were selected. And it also gives you this handy little disclosable graph or tree of the methods that it called. So it called map differ with a map differ with the int differ. So that's kind of nice. I'm sorry it's so tiny though. I cannot zoom in. But yeah, try that out yourself. It's pretty useful. But let's see what happens when we render this. I'm assuming it's going to look ugly. Oh, there's an issue. Could not find implicit parameter differ diffing. Ah, that's odd. IntelliJ could. Interesting. Did I ruin something? Could not find implicit value for parameter differ. Diffing.
Of a map of
a map of a map. I would have thought I could have done it recursively there. Maybe I need to give this a type or something. Maybe it's just confused. Oh, and you know what? I've screwed. It seems to have because of this one not of being empty, it's confused and it sort of has given it this strange bound here. So this is an empty map of let me just give these, if I give this an actual type, it won't be confused.
Yeah, I think that's right. Yeah, that bound is, well, especially with the, yeah, the invariance of maps. Yeah, that's gonna
Yes. So that
make
that
searches
confused
for
it.
you.
So yeah, sometimes adding explicit types might help its search because yeah, it couldn't find one for underscore of string. I guess I understand. Fine. So now it should be able to find it. And good. And it definitely looks ugly because we didn't handle a nice nested output in our renderer, but it sort of has the right stuff. So if we see what we have, basically they both have the first map. And so then it's going to recursively diff, and we basically get the original diff inside of this nested. It's not indented here, but it should be, and we'll fix that in a moment. But it's 1 is the same for these nested maps, 2 changed from 2 to 3, 3 was removed, 4 was added. The second map was identical, so it just is second equals map, right? They both had second empty map. Doesn't matter how I write it, it's the same value. And then fifth was removed because it was in the first one, not the second one. Fifth, good, 300, that's gone. And fourth, is added hello 300. Great. So let's just quickly touch up the rendering, and then we can get into some doing this sort of automatically for custom user case classes. Where's my render method? Def render, there you are. So the problem really is that this rendered thing, when we render all of our labels and make a string, it's calling make string and generating a single nested string. And what we kind of want to do is, for each of those inner strings, we want to indent them a couple of lines. And this still isn't the right solution, but I'm going to start with this. And it's going to kind of work in this first case. First map, yeah, sort of, not perfectly. It mapped just the labels. It's not ideal. Basically what we need to do, because these can just keep being nested and nested and nested, is that we sort of, it's not the most efficient thing, and that we can fix this. We want to write a method that basically splits any string on its lines, indents each of those lines, and then joins them back together. So I'm just going to do this, indent string, string, lines, iterator, map. That's basically it. Let's see if that works. So I want to indent the rendered a couple of lines. Yeah, sort of. And I kind of also want to separate these with commas. Okay, maybe not perfectly perfect. First equals map, those got indented, and that was there. That got indented a lot. I think it's probably because of doing that. So 1, 2, yeah. First, second, fifth, fourth. Yeah, it's not perfect, but it's fine for now. Maybe to finish it off and make it pretty, I'm going to have this synthesize red and green. And let's go cyan. So some string colorers, and then we can make additions green, removals red, and then differences cyan, which will actually show up as orange in my theme for some reason. So that maybe is a little more readable. So map, first we change the second value, and so on and so forth. Not bad. Not terrible. Any thoughts or questions?
Let's check. I don't think we had any before, but yeah, no, I think we are good.
Great. Okay, so now the next thing to think about would be, what if we had our own custom types? So let me make a person. Case class person, name string, age int, coordinate, and we'll have a coordinate type with an x int and a y int. Great. Maybe I won't even have the coordinate at first, because that's a little much. Because at first I want to sort of write one of these by hand, or maybe I could even have Copilot help me. It's going to be a little simpler than the map differ. Let's put our person down here at the bottom. So what would it look like if we put an implicit val differ, person differ equals, yeah, that's not quite what we want, because what we instead want is, if they are the same, yeah, we want them to be identical. Otherwise, we want to, yeah, basically diff the age, diff the name, and then put that in a list. Of course, these are going to be labeled .diff name, and then that. So we kind of want to go through each of the parameters and diff the values if it's not fully identical, and then just throw that in the list. So that's kind of the nice thing about being able to use this nested diff result structure is it works for a map. It'll work for a list if we were to implement it for a list. And it'll also work for people. Maybe I can get this to, let's see how good it is at def list differ. Good luck. Show us what you got, Copilot. It's thinking. Oh, compiles. Added. All right. I'll just trust it. I'm not going to worry about that right now. It compiles. That's kind of impressive. Added plus removed. Added contains. Yeah, 0 until old length. I don't think that's entirely correct. But it's a nice try. It's a nice try. I'll keep it there for now. Maybe we could tweak it later. But anyway, this is a person differ. Let us make a person into an object and diff it now. So differ.diff. Let's make okay. It's going to make 2 people for us, John and Adam. Okay. Prince. Yeah. These, by the way, these ages are just pulled out of Copilot's. Not giving out any PII here. So yeah. Their difference. Let's render these. So yeah, John became Adam, 30 became 35. If they were both named John, then we should see that's the same, and just age has changed, so on and so forth. So we've created our differ. However, one could might imagine that doing this for every type is going to get really annoying, and it's also going to be quite boilerplatey. For instance, where did my chord go? Chord. Let's just have it do this for us automatically. Sorry. Okay, so now we want a chord differ. I'll let this do it for us. It looks almost identical, nearly identical, except the fields have changed. That's really it. The fields and the constructor has changed. And maybe it'll have more or fewer parameters, and we'll have just more in this list with more calls here. Okay, great. And now if I actually do go to my person and add a coordinate here, and we'll just throw a couple in here. So chord 10, 15. And I don't believe this is Adam's coordinate, so do not try to find him. Oh, of course, because this is not being done automatically for us, we need ourselves a chord diff. Chord diff. And let me make this like this, and now I can find it. Okay, sometimes you need to add type annotations for at least IntelliJ to figure them out and find them. I'm not sure if that's actually true. Let me run this real quick. So now let's see if it can diff these nested things that we've written manually, painfully, or only semi-painfully because we relied on Copilot to do it for us. And yeah, there we go. The name has changed, the age has changed, and just one of the parameters of the chord has changed here, which is pretty cool. And I'm just testing something. Also, sorry for that. Yeah, so I couldn't find one. So yeah, sometimes you do need to, in fact, give type annotations here. I don't know why it would think it was otherwise, but for some reason, sometimes you should always give a hard-coded type to your implicit values. Great, but this is painful. And just to look one more time, it's sort of the similarities here. We have a person differ, and we have a chord differ, and it's basically the same hunk of code. So how do we deal with this? How do we deal with this painful duplication? That would be the question. Okie dokie. Well, we use a library called Magnolia. Magnolia. And luckily I have that there. By the way, there's this extension called paste, which gives you this thing, which is just my favorite Mac utility ever. It just stores everything to your clipboard in here and with like syntax highlighting. And they don't sponsor this either, but it's a lifesaver. Anyway, so yes, now I added Magnolia. I'm going to reload my project. And then we're going to use Magnolia to do this. So it's a really great tool for basically solving this exact problem when you want to create derivable case class instances. And that's how we use, that's what we use in a lot of Zia libraries for like deriving generators or for deriving, I believe, JSON and other things. Sometimes we make our own custom derivers as well, but it's really useful when it does work. And I also have a little Magnolia example because there's a bit of boilerplate and I can walk through it. So I'm going to pull this in here. Also, I think the last thing I need to do is add Scala reflect. Hopefully this can come on. Yeah, Copilot's also good at adding dependencies. So we do need to enable macros, otherwise we'll get some weird issues there. So I'm adding the macro library. Cool. Good. All right, so this is giving us, this is some boilerplate from their docs, essentially, deriving a show instance. So a show instance would basically be another type class that we just can sort of generate a string for something. But maybe it'll be good to just walk through this very quickly. The first thing is you need to sort of declare what your type class is that you're deriving so that the macro knows. And then you define these two methods, one for handling case classes, as you see, case class, and another one for handling sealed traits. And basically what you do is you implement an instance of you have to return an instance of your type class, given some information that you have in this context. And a few of the things that it gives you are the parameters, which is a sequence of this other parameter type that inside of it has a couple of things. Jump to it. Nope, not that. Param. Can we see what it has in it? It has a lot of stuff. Most importantly, it has its name. So it's the label, essentially. It has its type name. In fact, this is actually not a very useful way of looking at it. So never mind that. It has its label. Where's this coming from? Read only param. Okay, this is more what's useful. All right, so it has its label. It has its type class. These are the things you're going to use the most. Its label, its type class. It also has its index. It lets you do some other fancy things. It lets you pull that value out of its parent type. So you can extract that basically p.dereference, which they're using here, pulls, like, say this would be name. This would pull the name out of the person. So value would be person. P would be this name parameter. P.dereference would extract the name. It'll basically call person. It'll call name on this value here. Type class gives you a recursive instance of this type class that you're defining. So for this to fire in the first place, it kind of requires that the entire subtree, every parameter type in your case class has a show instance for it. Or that it's another case class or sealed trait, because then this will fire recursively if it's implicit. So yeah, basically what this is doing is we're defining the show method to take some value. We're going through each of the parameters in that value, and we're printing it out as the parameters label equals calling the show of the parameters type class. So if it's string, it'll call the show strings show method, and then passing along that parameter from the value, which it happens to know is going to be the right type. And you actually even get type safety thanks to some path dependent types. So I can't just put in 1, 2, 3 here because it needs to be p.field type or something. And you can only get that by dereferencing its parent type, which is pretty neat. And that's basically what we're going to need for here. So let's just change this to derive differ. And so I'm just going to change show to differ. I'm going to change the type T because I don't know. I'm an alphabetical type man. I don't know. It's
I
Zio.
feel like the T seems good when you only have one type, but it never scales when you have more than one type, which you inevitably do, and then you're just better off starting at the A.
I think that's the reasoning. I don't like going TUV all math style.
No, that's very weird. Yeah.
So let's try to do this for here. And I will once again, hopefully disable Copilot because I'm not sure. It'll probably do it well. We're not going to worry about the seal trait instance just yet. And let's take a look. Okay, so what do we want to do? Well, if A1 is equal to A2, and luckily, thanks to the magic of Java, there's equality built in here, so we don't really need to worry about doing any special thing. We can say identical, and then just put in one of the A's. So it's exactly sort of the method that we had before. And basically, we can go down to one of these things. So yes, let's take what we had for person and just jump and just throw it up here in a comment. So yeah, if it's the same, it's the same. We did that. Otherwise, we basically want to create a list of labels by going through each of the parameters. So let's say val labels. So this is going to be a list of labeled. We don't know how we're going to do that. And then we eventually want to return diff result nested with these labeleds in there. Except we don't want to say person here. Instead, we want to get the name of our type, which is going to be different here. So we'll replace everything that's hard coded and instead do context, which is the case class, the type name, and we can either pick full or short. I'll do full, so this will be fully qualified. So it'll be, project.differ.person or what have you. And now for each of these labels, we just have to basically go through all of the context's parameters and then map it. And is that a list or a sequence? It's a sequence, so let's list it beforehand. We'll get each parameter, and then let's copy one of these guys. And so what we had here was, well, the name is going to now be param.label. And instead of doing differ.diff, because this was previously summoning an implicit differ because it knew the types of these, now we no longer know that, but we do know that we just have an instance of differ. So I can say param.type class, and call diff on this, because it's a recursive instance of the type class. And where we were just calling a1.name and a2.name, now we need to use that param.dereference for a1 and for param.dereference for a2. And that's it. And theoretically, this will work. And it doesn't know what the word labels is. That makes sense. Great. So now theoretically, we can go back here and delete our manual instance. Actually, no, we don't want to delete everything, but we do want to just say derive differ.gen, and it can figure out the type based on the call site. And we should be able to delete actually this from our code. All right, let's do that. And so now it's way simpler. Let us see if this still works. Hopefully it does. And it does. And to prove that it does, let's also add a Z position to our chord. Why not? This is the simplest thing I could do. 100 and 9999. And is it going to know? And there we go. XYZ. Z is also changed. So yay! You too can derive type classes for things. It's like Magnolia is a pretty beautiful library. Really impressed by it. And there's all sorts of other fancy stuff you can do. We could show off the way to do type classes. I mean, to do a seal traits may as well. So currently, there's no way of doing something like, let's say, seal trait job. And I'll say case class chef. Number of bananas, int, extends job. Let's see what else it can do for us. Waiter, number of dishes, okay. Okay, let's do a programmer. What do we got here? Number of languages, okay. Number of bugs, I wish there should be some different types, but whatever. And then we'll also give every person a job. Great. So let's do that here. Job.chef2, chord 1, 2, 3. And yay, I made you a programmer, Adam, and you only have 3 bugs. That's a record.
Yeah.
Cool. Now if I run this, it's going to fail because the method split must be defined in the derivation object to derive type classes for solid traits, which is pretty great. It's a decent error message. So let's go up here and derive and generate the split method. So it works a little differently, but we do get this context object. So let's think about what we want to do here. So let's start with this. So first of all, they could be equal again. And if they're equal, A1 is equal to A2, well, then it's if result identical A1, that's the same. Otherwise, what do we want to do? Well, if they are different cases, we cannot we just have to say they're different. Like if one's a programmer and the other one's a chef, we cannot compare them field-wise. So we kind of just want to say that they're different and show the full case classes on either side using that sort of that diff result dot different A1, A2. So that's fine if they are different subtypes. But what if they're the same subtype? How do we even tell if they're the same subtype? So there's this method called ctx.split, which is a little strange. You give it a value, and then you get a function from this thing called a subtype. And the subtype has a method on it called cast, which is a partial function from the type to the subtype. So we can basically try to cast each side. Well, we know it's going to work for A1 because we got the subtype from A1, but we can see if it's also going to cast A2. And because it's a partial function, we can actually extract it to an identifier like this, and then do A1, comma A2, match on this, and use it as an extractor. So I can cast A1, cast A2, and use it as an extractor. So there we go. If this works, we know that they are both the subtype, which is kind of cool. So now we can say subtype dot type class dot diff A1, A2. Which is kind of definitely stranger than the other one, but totally should work. And let's try it now. Haha! No, I'm in the wrong part of the code. Wrong part of the code. But it does work, yay! Because chef is not the same as programmer. Of course, if we made them both programmers, and because he's not here, we'll give John 28 bugs. And now it will actually show the number of bugs being different. And we could go and add favorite language string. And if those are both, say, Scala, those should be shown as identical. So we're just sort of recursively nesting in here, and there's favorite language Scala. So we can handle seal traits, case class hierarchies, and it does all this fancy stuff for us automatically. So it's just, not that much code, a couple hundred lines, I guess, but we pooped that out pretty quickly. And there's also some notes. I mean, it took an hour, really, exactly, almost, with talking to do that. And I don't know, that's pretty cool, I think. I love Magnolia, and I love diffing. Any thoughts?
Yeah. Yeah. All right, let's see.
Check the questions. People are happy about Copilot for sure. What was the name of that app? Oh, a Paste. Paste is this thing. Paste app. Paste app, good. Yeah, oh yeah, there's IntelliJ clipboard history, I guess. But those were things I copied from the internet, so they weren't there. Into max value. Yeah, my bugs overflow back to 0 or to a negative.
I was gonna be like, oh, no, not in dot max value, long dot max value.
Damn. Big decimal. 800.9 bugs. So you only have to divide the instance per person. Yes, that is correct. So I only had to do this for person but it did it recursively. And Magnolia, the newer version, made this really nice because if this is implicit, it'll do it recursively. If it's not, it will not do it recursively. So you can sort of pick. So now it can't find it. Now it can't find a job. And it's awesome. It can't find it for a job. So it'll tell you exactly what it can't find a thing for. So in this case, if I had it semi-automatic, we would have to explicitly derive one for each custom case class type, which can be a good thing to do in some cases. But here I will make it implicit, so it'll just keep going and find itself in its own loop. I believe, though, it might even be possible, I could be wrong, to import derive_differ.gen and just have it work. So that basically like acts as auto. So that's kind of cool. So if you want auto, you just import the generator itself, and with the new versions of Magnolia, you get automatic deriving instead of the other one. Of course, then it has to be implicit here. So I don't know. There's probably if you want to give people control between semi-auto and auto derivation, you probably need to have like a different trait or something that made that macro implicit or something. Not entirely sure the best way of doing that. There are probably some patterns in their docs or something. But for now, hey, that's not bad. Now we have it automatic. I didn't know that. But then auto derivation is evil. I don't know if anyone has heard the book song. I didn't know that. It's quite insane. Recommend it. Maybe we could watch it because we have 20 minutes left. But yeah, that's it. Yay, diffs, diffing, how to sort of do a type class library and the power of implicit code synthesis plus Magnolia for deriving it for case classes is a pretty full, powerful combination full. And my brain is doing all sorts of crazy things. So maybe it's good that we finished early. How do you feel, Yigal?
I feel great about this. I didn't know about the automatic import of Gen because we do use Magnolia at work for very similar use cases. And I didn't know you can just import Gen. But then
I think it's one of their newer things, and with a nice sort of rewrite that it got after it went to Software Mill, or the people adding some stuff to it. I think they cleaned it up. Whoever's maintaining it now was doing a good job.
Right.
Also works for Scala 3, though there's I got some issues with sealed trait. Was that Magnolia or standard lib? Oh, that's also, so these sealed traits, where did I go? Derived differ, these case class and sealed trait types. These are, well, both case classes, I think, or final classes even. These come from Magnolia. So this is all part of Magnolia's cool innards. Nice, beautiful innards of Magnolia. Yeah, really, they made it really nice and simple. Join and split, case class, sealed trait. Feels good. I mean, it's crazy how few lines of code you need. And you can do also.
I have one tip for you, just a tip. There's a tiny little icon in your bottom right corner on the status bar, which is to toggle Copilot on and off.
Oh, so I could have done, well, I do know the shortcut. I just wish, oh, there we go. I can look at that to know whether it's enabled or not. So I can hit my shortcut. Right. And now that is, so I accept your tip and I will grow as a person.
Right.
I will synthesize that advice. Cool. That is very useful. Nice. What am I downloading and uploading so much? What is going on? Because of yes, Adam's here. We're doing the.
Oh, right.
Adam, where's your hello? No, Copilot's too good at generating mush. No human can compete. Great. I hope it's not too confusing. I have been told that maybe it allows me to move too quickly because I sort of anticipate what it's going to generate before it's generated it. And let me know if I'm moving too fast ever. But luckily we have recordings.
I think there can be some of that sometimes, or it just kind of takes the takes the wind out of your sails of you're like, so we're going to need to do this, and whoop, it's there.
It's just going to be crazy, yeah, and then it just does it. should probably delete this invalid list thing. I don't think that's correct. But yeah, there's some code. I will throw it all here. Oh, wait, no, okay, it did it as a text file. Great, cool. The paste Mac thingy is called what again? It's called paste. The paste Mac. Wait, where'd it go? Did I write? I thought I wrote this. It's gone now. Oh yes, paste. It's called paste. So sorry. It's probably thought I was being generic, but it's called yes, exactly. Paste. Is there a way to see it? It does have a subscription. I'm sorry about that. It costs like $10 a year, but for me, it's the only thing worth having. But yeah, anyway, enough advertising. That was fun. Thanks everyone. Until next week. Bye everybody. Bye Eagle, special guest.